Welcome back, my friends, to 6.1D, Spatial Scales and Time Scales. If you have not already, you need to pick up the blue paper for 6.1D. And we'll go ahead and start with a mountain joke. Let's see. You should always dress warm in the Andes Mountains. That place is chilly. And it Chile's the country was part of it. All right. Here we go. So as we talk about spatial scales and times today, you're going to see and hear examples of how the Earth changes based on spatial scales and based on time scales. Models or these scales often help us understand events that are too small to see or just too large. You'll start on the left-hand side of your paper by writing these four pieces down. You'll write the word global, region, observable location, and microscopic. Go ahead and pause the video and unpause when you're ready. All right, welcome back. As far as spatial size, it's the extent of an area where a phenomenon occurs. In this top picture here, there are global phenomenon that occur with global warming. For example, winds can be global as well. Regions are smaller than global, but they're too big to see the entire region. So this is the region of the Grand Canyon. It's too large and too vast to see, so these are called regional scales. You can also have an observable location. An observable location is going to be what's directly in front of you, whether it's this group that's here. I believe they are rafting in the river of one of the Grand Canyons. Your classroom can be an observable location. The TV in your couch is one of my favorite observable locations because I can see all of it from where I am. The last, these are grains of sand, and they are microscopic. We talked about these in our first unit, how they're too small to see. So drawing them in scale allows people to understand the process and phenomenon. In this next section on the right, for each one of these blue terms, time scale, you will write the word of an example as you go through. So go ahead and pause the video and then unpause when you're ready to go on. All right, welcome back. So the first time scale is millions of years. And in millions of years, looks like we have a little grammar commercial here. The event that occurs in millions of years is this. And what you're watching here are either, you can write plates moving, or this is plate tectonic. This takes millions of years to occur. Uh, we won't see anything like this happen in our lifetime. So please make sure that you go ahead and write millions or plate tectonics next to millions of years. Something that can take years to happen. In this case, this is in Peru, in the country in South America. And there's a river who has changed, not who, but that has changed direction. This is what the satellite picture looked like in 1985. And over the images over the next 28 years or so, the course of the river changed over time, which means the water changed direction and began to create what's called an oxbow. And here are all the pictures together. And see how it created a brand new river or a brand new formation. And so for this one here, next to years, you can go ahead and write a river changes its course. That will take years to see. Something that can happen in days is going to be a volcanic eruption. Volcanic eruptions can definitely happen over multiple days. This is Kilauea, and this is going to be erupting for days. This is the exact moment in the beginning of January that Kilauea exploded. What you're watching is 165 feet tall lava explosions. That's 16 basketball hoops, to give you an idea. So you can write volcanoes, that's what happens in days. Now in minutes, you can have an avalanche. And this is a planned avalanche, but it takes minutes for the snow to get from the top all the way down to the bottom. You can see it starting to move down this section. It's going to move over on the eastern side here. Down below, there's a building. So it's a building about the size of our PE locker room. So you can get an idea of how much snow this really is as the avalanche occurs. Once again, an avalanche is um, tons of snow that's coming down. You're going to see it cover these buildings here in just a moment. This can go on for minutes, depending on how tall the mountain is. And our last one, which occurs in seconds, you can write earthquake. And this is in 1989. In just a moment, you're going to see, and this all happens within a few seconds. It's the same time, but different cameras. And you'll see this room begin to shake. People begin to run for cover. You'll see objects falling from the roof. You'll see inside of a gym, lights shaking back and forth, buildings moving, even trying to get out of a business is a challenge as well. All right. So make sure you write one example for each on the right-hand side and have a great day.